In Chapter 9, Part 4, we're looking at absolute value inequalities. So number 48 says what values would make the absolute value of x equal to 3 true. So if we think about this, what could we plug in to the absolute value to make an answer of 3? Well, that could be 3 or negative 3. Either of those would work. So what values would make absolute value of x less than 3 true? So if we think about what would make this true, it's going to be anything in between negative 3 and 3. So any number in between negative 3 and 3, not including the 3's, so they're going to be open points, would be a solution to this absolute value inequality. So if you think about it, if you wanted to try plugging in negative 5, so if you take the absolute value of negative 5 is less than 3, absolute value of negative 5 is positive 5, which is not less than 3, so that's not going to work out. And then we could try maybe positive 5, just to be sure. Absolute value of 5 is less than 3. Absolute value of 5 is 5. 5 is not less than 3, so that's not going to work. So it's going to be anything in between negative 3 and 3, but not including those values. So number 49, what makes absolute value of x equals negative 3 true? This is kind of like a trick question. Nothing is going to make this true. So anytime you have absolute value, your result is either a positive or a negative. So absolute value cannot equal a negative. So what values make absolute value of x less than negative 3 true? So this is also going to be none. If you think about it, if you plug some number in for x, so say we plug in a negative number, we plug in negative 5 for absolute value is less than negative 3. Absolute value of negative 5 turns into a positive 5. 5 is less than negative 3. Does not work. Say we plug in a positive number. Say we plug in 7. Absolute value of 7 is less than negative 3. Absolute value of 7 is 7. 7 is not less than negative 3. So that's not going to work either. So no matter what you plug in for absolute value of x, it will always be a positive answer. So it will never, ever, ever be less than negative 3. So there is no solution. There's no values that would make this true. So no solution is when the absolute value bars, when isolated, are set to a negative value. So we just saw that in the previous example. We cannot do that kind of problem. So number 50, we are going to consider the inequality absolute value of x minus 2 is greater than 3. We are going to solve it similar to an equation. So we're going to take the x minus 2, get that absolute value by itself, which it already is, and then we'll do x minus 2 equals negative 3. So remember, we're doing two equations. So I'm going to add 2 to get x is equal to 5. Add 2 over here to get x is equal to negative 1. So when we go to solve our inequality with absolute value, we're going to do the same kind of thing. We want to make sure that absolute value is isolated, and if it is, we are going to rewrite it as x minus 2 is greater than 3. So you're just removing those absolute value bars for one of the inequalities. The second inequality is still x minus 2, but now we are changing the inequality symbol, and we are also changing the sign of that answer. So two things are happening. So we are going to solve for x for both. So x is greater than 5. And then over here, we're going to add 2 to both sides. X is less than negative 1. So we are going to plot these. So x is greater than 5. That's an open point with an arrow going to the right. X is less than negative 1 is an open point with an arrow going to the left. So we're going in opposite directions. So anything bigger than 5 would work, or anything less than negative 1 would work. So you could plug that back in. And just to check, I'm going to try something. I'm going to try to plug in 2 and see if that works. So if we do 2 minus 2, absolute value of 2 minus 2 is greater than 3. 2 minus 2 will give us 0. So absolute value of 0 is 0. 0 is not greater than 3. That does not work, and that proves that that is not one of your solutions. So listed here are the steps to solving absolute value inequalities. So the first thing you want to do is isolate that absolute value, and we did that in previous chapters. You're going to take the absolute value bars away to solve. So the first solution, you are going to leave it the way it is. So you're not going to change anything, just get rid of those absolute value bars, similar to what we did in the previous problem right here. We just took the x minus 2 is greater than 3. The second thing is second solution, you're going to flip the inequality sign and solve for the negative value, which is what we did here. So in this example, we are going to start by isolating that absolute value. So you can see right now that it's not by itself. We got this 2 out front that we want to move over to the other side of the problem. So this 2 is being added to the absolute value, so we are going to subtract 2 on both sides. So absolute value of x plus 5 is now greater than 1. So once that absolute value is isolated, we are going to rewrite the first inequality, x plus 5 is greater than 1. And then we can write the second inequality, which is x plus 5 is now less than negative 1. So you must change that inequality symbol and change the sign. So we can solve for x for both of these. So x is greater than negative 4. Subtract 5, and x is less than negative 6. So on our number line, we'll have our points. So we have an open point at negative 6, and since x is less than, it's going to go to the left. We're going to have an open point at negative 4. Since x is greater than, it's going to go to the right. So we have that OR inequality. In example 51, the absolute value is already isolated, so we are going to just automatically set up our 2 inequalities. So v minus 7 is less than or equal to 3, and v minus 7 is greater than or equal to, because you're going to change that inequality, negative 3. So we are going to solve for v for both. So v is less than or equal to 10. Add 7 on both sides here. V is greater than or equal to 4. So on our number line, we are going to put these points. So we'll have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll have a closed point at 10. So v is less than or equal to 10, so that's going to be going to the left. We're going to have a closed point at 4. V is greater than or equal to 4, so that's going to be going to the right. So this is going to be one of those AND inequalities. So everything in between 10 and 4, including those values, are going to be a solution to the inequality. We're going to jump down and take a look at number 54, and we want to get that absolute value by itself. So currently it's being divided by 3, so we're going to multiply both sides by 3. So when that happens, these 3's are going to cancel out. So we have absolute value of 4 minus h is less than or equal to 3. So we are going to now split this up into the 2 inequalities. So 4 minus h is less than or equal to 3, and 4 minus h is greater than or equal to negative 3. And we are going to solve for h. So I'm going to subtract 4. Negative h is less than or equal to negative 1. Because we're going to divide by a negative 1, this inequality symbol is going to reverse. So we have h is greater than or equal to 1. Subtract 4 over here. Negative h is greater than or equal to negative 7. We're going to divide by a negative, so that inequality symbol is going to switch. So we have h is less than or equal to 7. So on our number line, we're going to have our points. So we have a point at 1 that's closed. So h is greater than or equal to, so it's going to go to the right. closed point at 7, h is less than or equal to, so that's going to go to the left. So this is going to be one of those and inequalities where everything in between is going to be a solution. And when we go to write this, we always write it from small to large. So we're going to have 1 is less than or equal to h, which is less than or equal to 7. So we're going to write it as a compound inequality. The last one we're going to look at is number 56, and we want to get this absolute value of p minus 3 alone. So we are going to break away, starting with the dividing by 2. So we are going to multiply both sides by 2. So it leaves us with negative 4 times absolute value of p minus 3 is less than 8. We will now divide both sides by negative 4 to get absolute value of p minus 3 is now greater than, because we're dividing by a negative, it changes that inequality, negative 2. So at this point, we have absolute value of p minus 3 is greater than negative 2. And we could break this down, but if you take a look at what's going on, we have absolute value is greater than negative 2. So if we think about absolute value, the answer is either going to be a positive number or 0. So no matter what we plug in to this absolute value, it will always be bigger than negative 2, because it's either going to be 0 or a positive number. So we are going to say that this is all solutions. So no matter what you plug in, it's going to be a line going forever. No matter what you plug in, it will always be greater than negative 2, no matter what. So you could try, plugging in 10 for p, or you could plug in negative 100 for p. It does not matter. Anytime that you have absolute value, you're going to get a positive answer or 0. So it will never be less than negative 2.